Welcome everyone to Khadija Academy for electrical courses. Before we start this lesson, make sure to subscribe to our channel for more electrical lessons and hit the notification bell. Now let's go and start our lesson. Hi and welcome back everyone. In this video we would like to discuss the selection of circuit breakers according to IEC standard, but this time with considering the derating factors. So as we said before that our circuit breakers must be selected as follows. Number one, the nominal current or the rated current of the circuit breaker must be greater than the design current value. This design value representing the load current. And I in the nominal current is the current of our circuit breaker. For example, if this one is 13 amperes, then the I nominal should be, for example, 16 amperes. So we select a 16 ampere circuit breaker like this one for our load. Number two, the IK representing the maximum possible short circuit that can occur in our location, and our circuit breaker capacity, ultimate breaking capacity, must be greater than or equal the short circuit level. And we said that we say ICU for industrial breakers, and we said it will be ICN, which is a rated breaking capacity for household breakers, as we talked about the difference between ICS, ICU and ICN in a previous video. So this is the breaker ultimate short circuit break capacity which obtained from the data sheet, and this is the maximum prospective short circuit at installation point. Now this is not only selected by IB, we said that we select based on IN. Now our circuit breaker are not selected only by IB. I'm talking about this nominal current. However, we have to make sure that these breakers will behave as expected in real world conditions. Now I will explain what I mean in this video. So we have the breaker rated current IN. This is the maximum current that the breaker can carry continuously under standard condition defined by IEC without tripping. So according to our IEC, we have 30 Celsius degree. This is the nominal temperature or ambient temperature for domestic or household or commercial circuit breakers according to this standard that we discussed before. And for industrial type circuit breakers, which are denoted by this IEC 6947 that we talked about before, it will be operating at 40 Celsius degrees. And the installation method will be free air circulation in a vertical position and 1 unit. Now these are the condition at which we will have IN. So for example, when we say IN equal to 16 ampere, it means our breaker will give us this rated value at these conditions. However, in reality, these condition doesn't actually occur. So for example, in some conditions, we have our distribution panel. So we have several circuit breakers that are side by side, and this breaker will give heat energy. So in this case, we need to reduce the rating of our circuit breaker. Another condition which is ambient temperature, in which our temperature is not 30 Celsius degree or 40 Celsius degree or higher temperature, let's say 50 Celsius degree. In this condition, we have to derate our circuit breaker. Now, why do we even do this? Because at higher temperature, well, let's think how the circuit breaker works. It works using it has two parts, thermal overload, and it has magnetic, most of the circuit breaker, magnetic tripping. This one is used for overload condition, and this trip unit used for magnetic tripping or short circuit condition. Now, what I'm concerned with, IN, is related to this thermal overload. Now, here our circuit breaker work is using the pi metallic strip. Now this one, when the current flows through it at overload condition, this bimetallic strip have different expansion coefficient. So the circuit, this one of these metallic or this metallic strip will start bending and trip our circuit breaker. Now this one will trip early at higher temperatures. So when the temperature increase beyond the operating temperature, this bimetallic strip will activate early, leading to early tripping of our circuit breaker. That's why we need to increase the size of the circuit breaker to prevent its early tripping. So here the first one, which is ambient temperature derating. So higher temperature causes the breaker to trip earlier. As we said before, they are rated between 30 and 40 Celsius degrees. They are typically like this, and for each 10 Celsius degree we need to derate by 10 to 20%. Now we don't just assume any derating factor, we look at the tables by the manufacturer itself. And at low temperature the bimetallic will take longer time to trip. That's why we need to overrate or uprate our circuit breaker. So some breakers may require uprating in lower temperature to ensure operation. So let's look at this table. These tables are from Schneider Electric. As you can see here, the Schneider Electric breaker. So we have two breakers here, IC60, and we have the compact, this one here. Now what's the difference between these series of breakers? This one is a miniature circuit breaker and this one is molded case circuit breaker. This one usually is used for simple applications like residential and household. This one is used in industrial applications. Now we will find that also this one has lower ratings, lower short circuit rating or ultimate braking capacity, and also lower nominal current. This one here has a higher current, and not only this one has a fixed thermal and magnetic tripping, so we can't control its nominal current or change its activation current or rated current, and we cannot change its magnetic settings or the short circuit current at which it will start activating or the magnetic tripping setting. However, this one can be thermal magnetic. We can control these two. Some breakers we can control thermal and magnetic, other we can control only magnetic. It depends on the type of breaker and its rating. Now we will see it has TMD and TMG trip units. The difference between them is that this one is used for distribution systems. This one is used for generator units, because this one can have latency inside the inrush current or latency in its own activation in order to avoid the tripping during the inrush current of our generator. Anyway, this is not our goal from this video. Our goal is to understand the ambient temperature rating. For example, for this series of breakers, let's take for example this 16 ampere. This is the rating of the circuit breaker. Now if you look carefully here at 16 ampere at this part here, 50 Celsius degree, so it means that these breakers gives us 16 amperes at 50 Celsius degrees. So this is the rated or nominal value at 50 Celsius degrees. Now when the temperature increases, we have to derate it. So you'll see that this breaker will be 15.7, 15.3, 14.9. So it means that it will activate early or trip early. Compared to when we reduce temperature, you will see that the current rating starts to increase, as you can see. So what does this even mean? So if you look at this curve or trip setting of the circuit breaker, we have this overload part. So this is the IN, for example, equal to 16 ampere. Now before it, no current will be active, no tripping of the circuit breaker. After it, the circuit breaker will activate dependent on how much is our overload. Now here at higher temperature, this value will be reduced. It will be like this, as if we have the settings like this. So this at 50 Celsius degrees. Let's say at 70 Celsius degrees, the characteristics will look like this. 14.5, like this, 14.5 ampere. As if we have a breaker and that will activate at a current greater than 14.5. So if we have a load with IB equal to 16 amperes, at 50 Celsius degrees, no problem at all. However, if we are operating at 70 Celsius degrees, the circuit breaker will see the rated current of the load as if we have a fault. So the circuit breaker will trip even if we are at normal conditions. That's why we need to choose a higher breaker. For example, we can choose that 20 ampere, because at 70 Celsius degree we'll have 18.3, which is more than what is required. Now if you look at the other table, this is exactly the same, but it has 40 Celsius degree. For example, 100 amperes, 100 amperes at 40 Celsius degrees. Higher temperature reduced, lower temperature increase. Okay, the second one, this is from Siemens catalog, and you can see that this is the circuit breaker rating at different type of circuit breakers and the rating at temperatures. So for example, you can see that this 630 amperes at lower temperature, no problem at all. However, as the temperature increase, you can see that we have a derating in our current. The current will start to go down, trip earlier. Similar for the other values. Now the second effect, or which is the mounting conditions, we said that our circuit breaker are usually installed in an electrical panel like this. So all of this circuit breaker will produce heat energy, and this heat energy will affect the bimetallic strip inside all of these circuit breakers. That's why manufacturers usually suggest a derating factor of 0.8 for grouped breakers. For example, if our breaker is 16 ampere, it will usually trip at 0.8 of this value. We will see how to select these breakers using these derating factors in the end. The third condition, which is altitude derating, according to IEC 6947-1, in this part specifically. Now the altitude of the side of an institution does not exceed 2000 meters. So our values 16 amperes, 20 amperes are given at this altitude less than 2000 meters. However, if the altitude increases than beyond 2000 meters, the air becomes less dense. Which means we have a less cooling effect of air. Not only this, but this also means that the air has lower dielectric strength, which means we can have an effect of arc flash. This part here, which you can see, is obtained exactly as it is written inside this part of IEC. So to summarize, lower air pressure at higher altitude means reduced insulation or dielectric capability of air, and lower air density means reduced heat dissipation. This requires the rating of voltage, current, and even braking capacity. The braking capacity according to the manufacturer itself. So here is an example. This is from Schneider Electric, this one from the website itself, and this one specifically for this circuit breaker C120. Now you can see that, for example, here they gives you the range from 0 to 2000 to 111 meter. The current and voltage will be exactly the same. However, if it is between these two ranges, you have to derate the current and derate the operating voltage or maximum voltage. Here you can see at this range it will be derated for voltage and current. Similarly, for this table, which gives us more values, you can see dielectric voltage withstand. This is the maximum voltage it can withstand at up to 2500 volt. And as the altitude increases, you can see this value starts to go down. For the nominal operating voltage, you can see at this value, maximum operating voltage, it will start going down. For the nominal current, you will see that IN will start also to go down as the altitude increase. So we have to take into consideration this factor. This one for Siemens, from Siemens catalog, and you can see number one, we have a different altitude, as you can see here. Number one, for braking capacity, ICU or ICS, the ultimate braking capacity or service braking capacity, it will start to go down as the altitude increase. Similarly, for maximum operating voltage, you can see it starts to go down as the altitude increase. Similarly, for operating voltage, goes down. The set current here will change, as you can see here. Now, what does this even mean? This is for the derating of the fixed breaker. So if we have a breaker with a fixed magnetic and thermal fixed and thermal magnetic, we can't change it, so we will select a higher value circuit breaker. However, if our circuit breaker is adjustable, we can adjust this value, IR, rated current, after which it will start activate. At higher altitude, I'm gonna change the pointer to higher value. Instead of activating at this value, I'm gonna make it activate at a higher value, like here. So as if I am changing my breaker. So when we set our current at a higher value, we make it trip later. As if instead of having a 16 ampere, as if I obtained a 20 ampere breaker. So this is exactly the same as the derating or choosing higher breakers. So let's look at this example here. When we set IN greater than IP in ideal conditions, and by adding the rating factor, this rating current will be as follows. So we have to make sure that IN, after applying the different derating factor, temperature, mounting, grouping, altitude derating factors, it must be greater than IP. Let me write it in a different way. So IN multiplied by all derating factors must be greater than or equal IP. This equation is exactly this one. Okay, so let's have an example. Let's say we have a load current. So this is IP equal to 85 amperes in an ambient 50 Celsius degrees and 3 breakers side by side at an altitude of 2500. Now from the manufacturer itself, we have these values for temperature, grouping, and for altitude. This obtained from the manufacturer as an example. So what we are gonna do is that we have to select a breaker that satisfies these conditions. So we have to get IN greater than the IP or the design current divided by all of these derating factors. So we have IN must be greater than or equal 116. We have these circuit breakers for IEC circuit breakers, okay? Because you will find that in the NEC it will be different. For example, if you look at here, we have 1016 circuit breakers in IEC. If I remember NEC, if I remember exactly, it was 15 amperes. So the derating, the circuit breaker values can be different in NEC from IEC. So you have to be careful what you are selecting or what type of installation or codes you are following. So IN greater than this value. So we look at here, we have 100 and we have 125. So we need greater than this. So we will select 125 ampere as a nominal current for this circuit breaker. Now let's have another example from Schneider Electric. From their website, find the nominal current for IC60N, the maximum load current, which is estimated to be 34 ampere. This is the IP design current. It is installed side by side with other circuit breakers in a closed distribution box in an ambient temperature of 60 Celsius degrees. Okay, so we have number one, derating factor. For grouping, we said that if we don't have it, we will assume as a 0.8. This is for grouping since they are installed side by side. Second condition, we need a derating factor for temperature because our breaker is in a 60 Celsius degree environment. Okay, so how are we gonna do this? Number one, let's look at our breaker. This is for our circuit breakers at different ambient temperature. So number one, we need greater than 34 amperes, and at the same time, so if you look at 34, which one as a nominal current, okay, as a nominal current, this one which is the 40 ampere, this 40 ampere is greater than 34 amperes, okay. This is without the derating factors yet. It installed 60 Celsius degrees. So let's look at the 60 Celsius degree column. Goes down here, 38.2. 38.2 greater than 34. So for the temperature value, it will be 38.2, still greater than this 34. Now we need another derating for grouping, which is 0.8. So we will multiply this by 0.8. We find it to be, after the grouping, 30.5 ampere, which is less than our IP. So first, we take a value greater than IP, and it was 40 amperes. Then we find its value at 60 Celsius degree or any temperature we want. So it became 38.2, still greater than 34. Then we applied the grouping factor, it was 30.5 amperes. Now this one is not suitable since it is less than IP. So we need a higher circuit breaker. Let's select, for example, 50 amperes. So a 50 ampere circuit breaker, let's delete this. 50 ampere circuit breaker at 60 Celsius degrees will be 47.6, as you can see. And then after applying the grouping factor, it will give us 38, which is greater than the IP which we want. That's why a 50 ampere will be suitable. Now, since we are designing for a distribution panel and we don't know exactly the ambient temperature or the condition that our circuit breaker is installed, many engineers, what they do is simply they take the IP, which is the design value from the rated current, and multiply it by 1.25 in order to get I nominal for the circuit breaker, if they don't know the derating conditions of our breaker. That's why many of our lessons we have multiplied the circuit breaker, the rated current, by 1.25 to get the size of the circuit breaker. So some engineers consider this as for the derating condition. Other engineers may multiply by 1.25 for future expansion. So it depends on why they do this or why do they add this factor. Thank you for watching this lesson. I would like to invite you to our academy, Khadija Academy Premium membership, which will help you learn more about electrical engineering. In this academy or in the academy membership, you will find that we'll have more than 100 courses in math, electrical engineering basics, power engineering career preparations. For example, we have electrical design, we have courses on electric circuits, power electronics, ETAB, MATLAB, solar energy, wave energy, wind energy, and much more. You can join our membership for just a small fee per month, or you can just have a lifetime access in which you will get all of current courses and classes, and you can have them forever. And not only this, but any new courses that will be created, you will be able to watch it for completely free. So what are the classes that I will learn in this membership? You will find different classes in electric circuits. You will find in transformers, magnetic circuits, machines, power electronics, load estimation, lighting design, lightning also design, earthing system, cables, generators, light current systems or low current systems, off-grid design, on-grid design, lots of classes and courses in different topics.